Hello everyone. So today's topic is force and laws of motion. Okay, so let us first see what is a force. Okay, so a force is any cause that changes the state of rest or motion of a body. Okay, so this is the definition. You guys can write it down. Um, what does this exactly mean? So in the previous chapter, we had studied about motion, right? So we read about the definition of motion and the types of motion in 1D, 2D, etc. So today, basically, we are going to learn about how that motion is caused. So we can see that the motion is basically any kind of motion is caused by a force. Now, whether it is an unbalanced force, what is the magnitude of the force, how it changes the state of the body, all those things we are going to discuss today. Okay. For example, if you look at the picture, you can see that here are three boys, here are three girls, and they are pulling a rope. So, from the looks of it, both are applying equal amount of force, right? On both these sizes. Now let's not comment that who has more strength here. Let's just see that here are three people and here are also three persons. Okay. So here we can see that it is more or less balanced because no one is pulling more than the other group, right? So here the rope is also taut and it is not moving anywhere. It's not inclined towards this side or this side. It is equally balanced. So this is a small example of a balanced force. Okay. For example, like there's a table on which you have kept a book. Now, if the table is not inclined, if the table is absolutely straight, you will see that the book is not falling. Like obviously if you keep anything on a table, why will it fall suddenly, right? So that is also an example of a balanced force. Why? Because the table is also exerting a force on the book and the book is exerting an equal amount of force on the table. Let us call it A and let us call this B. So A equals to B, as a result of which the book is ekdam static, it is not moving. Thus, this is also an example of a balanced force. Okay. So, from this example, you can understand that balanced force will not exactly cause motion, right? Because if you see in this picture also, there is no motion, like net motion is zero because both of them are pulling equally hard. And in this case also, the table and the bookcase, here is the book is also not moving. So this gives us an idea that balance force is not exactly what causes the motion. It is basically an unbalanced force. Okay. So we are going to discuss about this a little bit more here. So yeah. So what you can see here is that an object, like here you can see that no force is being applied. Like let's call this 1, 2, 3. So here you can see that the object is at rest, right? Because no force is being like from anywhere being acted on it. And if you consider that this is like a ground or something, then the ground is also equally exerting a force and the stone is also exerting an equal amount of force. So the stone is static. Now two people start coming and pushing it. Okay, let's assume that both of them are pushing the stone at equal strength, like equal force. So again, it is static. Why? Because the force, let's call this man A, let's call this man B. So force exerted by man A is equal to force exerted by man B. At the same time, the stone which exerts force, this force that the stone exerts on the ground, it's called basically its weight, which is its mass into acceleration due to gravity. So yeah, so this is basically m into g, which is the weight of the object. This force is basically equal to the force exerted by the ground on the object, which is basically called normal reaction or normal force. So since normal reaction is equal to the weight of the object, and at the same time Fa equals to Fp, so the net motion of the body is 0. Okay. Now let's take up the third case. So here what's happening, an object acted upon by an unbalanced force changes the speed and direction. So you can understand here that both the guys have come on the same side. So now instead of Fa equals to Fp, it has become Fa plus Fp. There is no resistive force here, right? Like there is friction, but we'll talk about that later. But friction is also not enough to overcome the force of both these men. So as a result of which, Fa plus Fp minus, okay, let's say the friction, which is coming from the ground this side, let's call it small f. This is basically what is causing the motion, right? This will make the stone move in the left direction. So you could understand that whereas this one and this one, both the first and the second cases were balanced forces, in the third case, when it became an unbalanced force, it caused motion. Okay. So with this, we can start discussing the laws of motion. By now, I think it's clear to you guys that what is a force and what is a balanced force and unbalanced force. So let's talk about the first law of motion. It is something related to this only. So the first law states that an object remains in a state of rest or motion in a straight line unless compelled to change its state by an applied force. Okay. So you can write it down. An object remains in a state of rest or motion unless compelled to change that state by an applied force. Okay. I hope my handwriting is clear, and even if it is not, you guys can just pause the video and see, and the PDF will be provided to you, so it won't be a problem. Okay. So with this, let's start the discussion about the first law of motion. What does it say? The definition simply means that unless and until you put an external force to any object which is either at rest or at uniform motion, it will not change its previous state. So in this world, everything like resists change. Okay, whether it is an object, whether it is us in our daily life, we are just doing the same thing. So unless and until someone pushes us or someone tells us, no, do something else, get up from your bed, something like that, we tend to be in the same state all day. And if nobody bugs us, we will not change our position. We'll be in the same state the whole day. In the same way, every object in this world has its own inertia or its own property by virtue of which it will not change its state of rest or uniform motion unless and until an external force acts on it. So this is what exactly is the first law of motion. Okay, so let's discuss some more about it. Yeah. So as I told you, inertia. Now, what is it? It is the property of an object by virtue of which it remains in the same state of rest or motion unless acted by an external force. Okay? So, yeah, so let's take up this example. It's a very simple example. You've observed it thousands of times whenever you've rode a bus, a train, a car, anything. Okay, so what is it showing? It's showing that, for example, you're driving a car, your seatbelt is on and you're driving it. Now suddenly, for some reason, you applied brakes. Okay, so as soon as you applied the brakes, your body, it moves forward, right? Like for a few seconds it moves forward, and then because of the belt you again regain your position. But the first thing that happens when the brakes are applied is that you tend to fall forward. Now why does this happen? As I told you, that inertia is the property of an object, so it obviously applies to humans as well, everything in this world. So due to the man's inertia, and also because when you are sitting, so you are moving along with the car, right? Like the car is also moving, and since you are inside the car, you are also moving in the same speed, right? You are sitting and your body is somehow in the same motion as the car because the seats are all attached to the car, right? So both of you have inertia. As soon as the car brakes are applied, your body, like the lower part of your body, here, let me show you, like here the lower part of your body is still in the contact with the seat, right? So it will stop. But the upper part of your body, it still thinks that you are moving. It still thinks that the car is moving and you are moving. So it will take some time to realize that no, the brakes are applied, so I will now stop. So before stopping, it will move forward. So what does this mean? That since the car was moving, the whole body was moving. As soon as the brakes were applied, the car stopped. The lower part of the body of the person driving the car in contact with the seat, that also stopped, but the upper part took a little time due to inertia of motion. It leaned forward because it had not yet understood that no, I have to change my motion from motion to rest. So immediately, like a few milliseconds after you lean forward, your body again comes back to rest, because now it has acquired its new inertia, which is inertia of rest from inertia of motion. So this is one example. The application of inertia is huge. I'll give you another example. It's a very simple example, yet we never thought about it while doing it. So do you remember, like, when your carpets are dusted, carpet dusting, so you realize that the dust, all, like, when the carpet is dusting, and let's say these are the dust particles, so the motion that you're doing, like going front, coming back, this motion basically, what is it, what is the significance, like why do we do that, like why do we do this motion so that the dust all falls down? Now what is the logic behind it? The logic is again the same thing, that the carpet and the dust particles, both, since they were together, they had the same energy of rest. Now you start moving the carpet very vigorously. So it takes some time for the dust to understand that, oh, we have to move. And by the time it starts moving, the carpet is already shifted. Right? The carpet has already shifted from the dust because it is here now, and the dust particles are still here. So what, the dust particle settles down. Again, when it moves here from here, the remaining dust particles here, they again cannot cope up with the inertia, they cannot cope up with the speed of the carpet when it moves back here, so the remaining dust falls. So like this, when the carpet is doing a to and fro motion, the dust particles constantly, they fall off. So this was a very easy example of first law. So yeah, now let's have some more discussion on inertia, what exactly it is, what exactly it does. So till now we were talking about cars and carpets. Let's just say that there are two different objects. So one, for example, is a small car. And another one is a large truck. Please pardon my drawing, it is not that appealing. Okay, so this is a car and this is a truck. Okay, so as soon as, like, imagine at first both are going on a straight road, no obstacles, nothing. Now suddenly there is a curve. Okay, let's draw it in a better way. There is an entire curve in the road. So now what is going to happen? See, both the car and the truck, both will take the turns. Okay, no doubt about it, obviously. But what you'll observe is that the car takes the turn faster than the truck. Okay. So now, what does it tell us? Like, why do you think that is? Could it be related to the fact, to the size of the car and the size of the truck? So, like, you can from very well understand that a car's mass size, it is way smaller than the trucks, right? So, the car, since it is like a lot less heavier than the truck, its inertia is again less than the inertia of the truck. So, what does this tell us? This tells us that inertia is basically dependent on mass. Inertia is directly proportional to mass. So the body which has less mass, it will have less inertia of rest or uniform motion, whatever it is. So we could understand that when the turn came, it was easier for the car to change its state of rest to that of motion, right? Because its inertia is less, and it took more time for the truck to take the turn because its inertia is obviously more because of its mass. So from here we get to know about another useful thing which you are going to need it. So you can mark it that inertia is directly proportional to mass. Okay. So with this we come to an end of the first law. Now let's talk about the second law of motion. So the second law So here we again discuss about some related topics only. So in the previous example we talked about a a truck and a car. So now let's look at it in another way, that suppose the car was moving and the truck was when the truck, both of them were on the same road, and suddenly a small vegetable van came in between, like in between the road, like it was crossing the road, and both the car and the truck, they were coming in speed, okay, like good speed. So whose impact is going to be more on the van? It is the trucks, right? Now why did we think that it's the trucks? This is because the mass of the truck is more, okay, and the obviously it's lesser, so that is one factor. Even if I say that instead of a truck the second object was also a car, okay, like they were both the same, both this one and this one, they were of the same mass, okay, like the mass is equal, but car number one, car number two, so car number one was approaching the van at, let's say, speed 20 meters per second, and this one was approaching at 30 meters per second. So again the same question, which one has a greater impact? Now your answer will be 30 meters per second. The car with the speed 30 meters per second. Now why is that? Because obviously it was coming at a higher speed, so its impact will be much greater than that of the car number 1. Right. So this gives us an idea that the impact on that an object creates, it depends both on its mass and its velocity, right? So this has a name, like the product of its mass and velocity, it is called momentum. So you can write it down like the product of the mass of an object and the velocity of an object. So now we can take the example of the truck and a car again also. Like even if the truck had a mass of 60 kgs and a velocity of 20, the momentum would have come to 1200. What is going to be the unit? Kg meter per second. So it will be kg meter per second, right? 1200. And at the same time, for the car, let's say it was 40 into 10, so it was 400 kg meter per second. So from this we can understand that obviously the impact of the truck is greater than the car. It doesn't always have to be that both have to have the same mass and velocity is different and etc etc. It's not like that. So anyway, yeah. So now, since we've learned about momentum, there is another aspect to it. One second. Yeah. So this is basically, we'll talk about here, like the actual, what the second law of motion says. It's basically that by definition, the rate of change of momentum is directly proportional to the force applied and in the direction of that force. Now here, it will sort of be the external force here, obviously. Okay, so now what does this definition mean? Like the rate of change of momentum. Like when we talk about rate, it means that anything that changes per unit time. That is the sole meaning of rate. So when we talk about the rate of change of momentum, मतलब initially जो था अभी उससे कुछ different हो गया है, which is the final momentum. So we can write it as Pf minus Pi, F stands for final, I stands for initial, divided by T is directly proportional to force. Okay. So इसको थोड़ा सा simplify करें. We knew in our previous discussion that P is for momentum, V is for velocity, M is for mass. तो हम लोग अभी इस equation को equation number 1 बोलते हैं. And here, sorry, and here it will be P minus pi by t is equals to, let's just give it a constant k for now, k into f. Okay, so we are going to be simplifying this a little bit. So it will be, sorry, it will be m. Now you know that mass is always constant, right? Like mass is a quantity that can never change. So there's no point in writing mf and mi. So we will directly write mvf minus mvi divided by t equals to kf. Sorry, this will not be an arrow. This will be an equal sign. Yeah. So we got this. Now this will basically suggest that when we take the m common, f minus vi divided by t equals to k to f, which implies, so in the first chapter, if you all remember, we know that the rate of change of velocity, it is given a term which is m into a, just acceleration, right? So this is our equation, and k is given the value of 1. So from here we get f equals to m into a. This is our finding. Here we can write in bracket that value k of k is 1 to maintain the proportionality. Okay. So in other words, we can form a definition of force by saying that force is the amount that is required to have an impact on a mass of 1 kg in order to produce an acceleration of 1 meter per second square on that object. So this is this derivation that we just saw. This is kind of important. It comes a lot in exams. So this derivation is sort of like a must. When you practice it, or in your higher studies also, you'll always like need this. Okay, so this will be all for today. For our next class, we'll have some more discussion on the second law. We'll discuss some examples. We'll try out some very simple sums on it, and then we'll move on to the third law of motion. So till then, thank you. If you have any doubts, feel free to comment in the section below, and the PDFs will be uploaded in the description of this video. Thank you. See you soon.